The topic we'll be discussing in this lecture is security services that are offered by GSM. GSM offers several security services using confidential informations that are stored in AUC authentication center and also in the SIM subscriber entity module identity module. The SIM stores personal and secret data, and also it is protected with a pin. The SIM contains personal and secret data. It is also protected with a PIN number. Okay. In order to ensure that it is getting used in an authorized way. So PIN stands for personal identification number. Basically, the security services that are offered by GSM can be broadly classified into three categories. These are access control and authentication, the first one. The second one is confidentiality, and the third one is anonymity. So under access control and authentication, it includes authentication of the valid user for the respective SIM. So the user needs a secret PIN to access the SIM. The SIM will be protected with a PIN number. Okay. And also it includes subscriber authentication. This is based on a challenge response scheme, which we will discuss soon. Okay, there are two steps of authentication. One is authentication of the SIM, that is with the PIN number. And then the subscriber authentication, that will be done by using a challenge response method that we will see during the course of this lecture. So this is the first security service offered by GSM. The next service offered is confidentiality. So basically confidentiality, in the sense, it ensures that all data that is transmitted over the air interface is encrypted. So this encryption is applied between BTS and the mobile station. This encryption is applied between BTS and the mobile station. Okay. So encryption is done on voice, data, and other signaling information. So it does not provide end-to-end encryption. The encryption is only between the BTS and the MS. So this is the second service offered by the second security services offered by GSM. The third security service offered by GSM is anonymity. So this service anonymity. It is provided to ensure that all data is encrypted before transmission, and the user identifiers are not used over the air interface. Okay, anonymity means if some data is traveling over the air interface, just by tapping over that data, nobody can identify the user who is sending that data. Okay, the user identity will be hidden. That will not be passed through the air interface. Okay, so instead a temporary number will be used. That number is called as TMSI, temporary mobile subscriber identity, which we have already discussed. Okay, so providing that service is called as anonymity. And also the VLR will keep changing this TMSI. TMSI will not be fixed, it will keep changing. So these are the basic three services that are offered by uh, three security services that are offered by GSM. And for providing these three services, the GSM uses three algorithms. These are, there is an algorithm called A3, which is used for authentication. And there is another algorithm called A5, which is used for encryption. And there is another algorithm called A8, which is used for generation of cipher key. Okay. Originally, GSM published A5 publicly. It is Anybody can see that algorithm. Initially, the algorithms A3 and A8 were kept as secret, but currently it is not a secret. A3 and A8 were also published on the internet in the year 1998. So these algorithms are not very strong algorithms. It provides some basic encryption. Okay, we cannot say that these are very strong algorithms. But if want to provide, network providers can use stronger algorithms for authentication. Say if some network provider like Airtel or BSNL believes that we want to provide more stronger authentication, then they can include. Okay, but GSM provides a basic level of authentication and encryption, right? Or if users also want, they can also apply stronger end-to-end encryption at their level if they want. Fine. So, next what we'll be discussing is we'll be discussing about authentication in detail. How authentication is done. So authentication uh, is done based on SIM. So before a subscriber can use any service from the GSM network, the subscriber must be authenticated. And this is done based on the SIM. The SIM stores the individual authentication key called KI and also the user identification IMSI and the algorithm which is for authentication. Okay. The algorithm that is used for authentication is A3. All these will be stored in the SIM. Authentication key, IMSI number and the A3 algorithm, that is authentication algorithm. So basically authentication uses a challenge response method. It uses a challenge response method. So how this method works in the sense, there is a block called access control. This access control, it will generate a random number called as RAND as a challenge. Okay. And this and using this so this random number will be generated by this random number will be generated by the mobile network, and it will be given to the uh, and it will be shared between the mobile station and also between the mobile network. It will be shared in the mobile station and also in the mobile network. Okay. So the mobile station will apply this random number on the key. Mobile station will apply this random number will uh, will apply this random number on the key using the A3 algorithm. Using A3 algorithm, it will apply. As a result, it will get something called as SRES, which is called a signed response. Which is called a signed response. Similarly, from the mobile network end also, this random number will be operated on the key using the same A3 algorithm. As a result, you from the mobile network also you will get an SRES. So both the SRES will be compared. If both are matches, then the authentication is successful and the user will be allowed to access the GSM network. Otherwise, he will not be allowed. So this is the basic functionality of authentication, which is explained in this diagram. Here we can see, so there is a random number is getting generated by the mobile at the mobile network end, and it is shared with the SIM for the mobile user. Okay, so using this random number, and KI is already available in the SIM. KI is the authentication key. So this so using this random number and using this KI key, this A3 algorithm is applied on this random number and on this key. As a result, whatever the user get is called as SRES. So this SRES, the user will share with the mobile network in the MSC part. Okay, so it comes here. Similarly, in the mobile network end also, using this random number and using the same key which is used by the SIM, the A3 algorithm is applied. As a result, in the mobile network also we will be getting another SRES. Both these SRES will be compared. If they are equal, then the authentication is successful. Otherwise, the authentication will fail. Okay. So this is how authentication works in GSM security services. Okay. Next, let us see how encryption works. So, so basically, encryption is done to ensure privacy. Okay. So all messages containing user-related information are encrypted over the air interface. After authentication, the mobile station and the base station subsystem can start using encryption by applying the cipher key KC. Okay. KC is generated using the individual key KI and a random value by applying the algorithm A8. KC is generated by using the individual key Ki and a random value over the algorithm A8. Use Ki and a random value on algorithm A8. As a result, what you get is called as KC, okay, which is a cipher key. See, the SIM in the MS and the network both calculate the same KC. Okay, the SIM in the network, the SIM, the SIM in the MS, the SIM is in the mobile station and the network, mobile network, both calculate the same KC based on the random value, based on the random value. Okay, the 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 KC, that is the cipher key, will not be transmitted over the air interface. KC will not be transmitted over the air interface, but MS and BTS can now encrypt and decrypt the data using the algorithm because they have got the same key, because they got the same key as they are sharing the random numbers. Okay, so let us try to understand this with the particular diagram. So here is the diagram. Here you can see is so in the mobile end a random number is generated, and that random number is shared with the SIM, okay, in the mobile station, and mobile station applies this random number and the key Ki, which is already available in the SIM, in through A8 algorithm. As a result of that, what you get is called as KC. KC. Now the mobile station uses this KC to encrypt the data. Using this key KC, any user data will be encrypted by the mobile station through the algorithm A5, by the algorithm A5. Similarly, in the network end, the whatever the random number generated, the network end also, this random number is applied with the key Ki. So both the keys are same on the same algorithm A8. So as a result, you will get a KC. So both these KC should be same. Both of these cipher key will be same. And now the mobile network, if it wants to send anything, it will encrypt this. It will encrypt this data using the. It will encrypt this data using the A5 algorithm, using the key KC, the cipher key. Okay. So encryption and decryption are done through A5 algorithm. So whatever the data the mobile BSS receives from mobile station, it will also it will decrypt it using A5 with the same key KC. Similarly, whatever the data the mobile station receives from BSS, that will also be decrypted using the same algorithm A5 and with the key KC. Okay, so this is how the encryption and decryption is done between mobile station and BSS, and this is how confidentiality is achieved in a GSM network. So, but these algorithms are basically not, you cannot say these are very strong algorithms. These are uh, these are not very strong algorithms. Okay, because if you see for the confidentiality case, the cipher key, the size of the cipher key is 64 bit, so which is not very strong, but it at least provides a good protection against simple eavesdropping. Okay? It at least provides a good protection against the simple eavesdropping. Okay, and the publication of A3 and A8 on the internet. So as we have discussed, A3 and A8 already published in the internet. So it showed that in some of the implementations, 10 of the 64 bits are always set to 0. Even though the cipher key KC, it uses a 64 bit, in most of the cases, in some of the cases, it was found that 10 of the 64 bit keys were always 0. So it means that the real length of the key is only 54 bits. It means that the real length of the cipher key is only 54 bits. Uh, so, uh, so, so the encryption is much weaker. Actually, we cannot say this as a stronger encryption mechanism. So, so that's it about the security services that are offered by the GSM. So basically, what we have discussed in the sense, the security, the confidential informations are stored in AUC and in the individual SIM. So this includes the SIM contains information like personal secret data, and also it includes a PIN. Okay, the secret key KI is also stored in the SIM for authentication and encryption purpose. And the basic security services offered by GSM are access control and authentication, and then confidentiality, and then anonymity. So in access control and authentication, there are two levels of authentication. One is authentication of the SIM, that is done by PIN, and the other one is authentication of the subscriber, that is done by a challenge response method. So that is what we have discussed in this diagram. So this is the challenge response method. So this is the challenge response method. So here basically the SIM is creating SRES, and that can be considered as a challenge. And then MSC should also generate the same SRES. So if both are matches, then the user will be allowed to access the GSM. Otherwise, he will not be allowed. And then we have discussed how confidentiality is achieved by encrypting the voice, data, and other signals uh, over the GSM network. But actually, confidentiality is only between MS and BTS. That is, the actual encryption and decryption happens only between MS and BTS. There is no encryption in the air interface. So basically, it does not provide end-to-end interface. And then we have discussed anonymity. So anonymity means the user identity will be hidden in the air interface. Nobody can know who is the user. By tapping in the air interface, somebody cannot identify that. So that is done by using a number called TMSI, temporary mobile subscriber identity. And this number also, this is applicable for each VLR. When a mobile comes in a particular VLR, it will get a TMSI. And this TMSI will also frequently update. It won't be the same thing. Basically, there are three algorithms to provide all these services. These are A3, A5, and A8. A3 for authentication, A5 for encryption, and A8 for cipher key. And then we have discussed how authentication is done by generating a random key using challenge response method. And also we have discussed how encryption is achieved by using a cipher key, and how the cipher key is generated in the network end and also in the mobile station end without exchanging any keys. Okay, so here there is no key exchange. Based on the random number, the random number is shared and they generate the cipher key and they start sharing the information, start encrypting and decrypting the data. Still, it was observed that these algorithms are not very strong, because here the KC, the size of the KC cipher key is only 64 bits, which is not a stronger case. And also it was observed that in most of the cases, out of the 64 bits, 10 bits are not used. So only 54 bits are used. So basically the encryption is a kind of weaker encryption. Okay. So that's it about the security services offered by GSM. Let us stop here. Thank you.